Hi everyone, Geek37 back with another video, and this is part 17 in my Exploring the Heptagonal Triangle series. And what I'm going to do in this one is I'm going to find the sum of the three sine ratios in the triangle. The sine of pi over 7 plus the sine of 2 pi over 7 plus the sine of 4 pi over 7. And this leads to a very interesting result that I found in the heptagonal triangle article on the Math World website. So let's start off by changing the ratios into their variable forms. So we get a plus c, or a plus b plus c all over 2r, because those denominators are the same. Now let's pause here for a second and go off to the right. There you see I have a couple of Ptolemaic identities written. Now the interesting thing is up above here we have a squared plus bc equals c squared, and below that we have ab plus ac equals bc. What I can do is I can rewrite the top one as a squared plus ab plus ac equals c squared. And you'll notice that those three variable components on the right side of the equation all have a in it. So what I can do is I can factor out a like so here. So I get a plus b plus c equaling c squared. And if I divide both sides by a, I get the perimeter of the triangle, a plus b plus c, equaling c squared over a. That is an interesting coincidence based on what was derived from above. But here's the thing. We know for a fact that c squared over a, if we were to divide this by 2r, we would get 1/2 times c squared over ar. And that again is 1/2 times tangent of 3 pi over 7. So let's go back up top here. We know for a fact that, again, the sum of the three sines will add up to get a plus b plus c, the perimeter of the triangle, over twice the circumradius. Now, here's what will happen. Let's go down here, rewrite that ratio, and then put that equal to c squared over 2ar, just like we proved down on the bottom there on the right side. And then we just showed that that's equal to 1/2 tangent of 3 pi over 7. So I can rewrite this as sine pi over 7 plus sine of 2 pi over 7 plus the sine of 3 pi over 7 equals 1/2 the tangent of 3 pi over 7. But here's the thing. The Math World article doesn't show the tangent of 3 pi over 7 on the right side. They show something else. What I want to do next is I'm going to take the tangent of 3 pi over 7. And what I'm going to do is I'm going to rewrite this as cotangent of pi over 2 minus 3 pi over 7. We're going to get the cotangent of something. Well, let's look at the second set of parentheses there, pi over 2 minus 3 pi over 7. Well, pi over 2 is equal to 7 pi over 14, and 3 pi over 7 is equal to 6 pi over 14. So if we subtract those, we get pi over 14. So therefore, the sine of pi over 7 plus the sine of 2 pi over 7 plus the sine of 4 pi over 7 equals 1/2 cotangent of pi over 14. And that concludes the video right there. I found that calculation quite fascinating. I never expected that that sum, while would not equal an exact numerical value or an exact integer value, it does equal to an actual trig value that relates to half of the original angle of pi over 7, and I just find that quite fascinating. The interesting story about this for me is I had derived this a number of years back when I started investigating the heptagonal triangle the first time, and I was trying to figure it out. Well, I did it in the trigonometric way, and it was quite complicated, but after going down the variable rabbit hole that I've done since the start of this series, I found this was a much easier way to derive that interesting calculation, and I wanted to show that to you today. All right, hope you enjoyed this video. I enjoyed making it. This is Geek37 signing off.